Hello everyone. In this presentation we were discussing about the metal casting, and in the last video we started about the pattern and allowances. Also we have discussed in that video regarding the theory part of the pattern, and we have completed the shrinkage allowances as well. We also discussed about the some of the numerical problems that has been asked previously in the gate examination. In this video we are going to discuss about the remaining allowances. Okay, so let's start with the second allowance, that is machining or finish allowances. Okay, as the name suggests that machining allowances or the where the machining process is required. Okay, now to understand this allowance we are taking two examples. First is first one is like we have to produce like 3 casting, okay, with the different of the same size with the different material. Okay, like we are producing a casting cube of 50 mm side, okay, with the 3 different material, that is here we are taking gray cast iron, plain carbon steel and the aluminium. Okay, all these 3 material have a different rate of contraction. Okay, now we are not producing here in mass or batch production, so just we are taking like we are producing only one one casting of individual material. So for that we are using a single pattern. Okay, now this single pattern is based on the rate of contraction of the gray cast iron. Okay, so if whatever the if we are using means the size of the pattern is defined and on the basis of the gray cast iron material, then the casting that we will get, that will be the size of the that will be the required shape and size. Okay, but whatever the casting, if we'll use the same molding same pattern or the for the mold cavity in which these material plain carbon steel or aluminium is filled, then the size of the casting will be different, because the rate of contraction of the aluminium and the plain carbon steel is different. So now what we have to do, if these dimensions hopefully these dimensions, because the rate of contraction is different, so these dimensions will be greater than what the dimension is required at the end. So if this dimension is greater, then we have to go for a machining process. Okay, so whatever the excessive amount of material is there, we have to remove with the help of the shaper or the milling machines, whatever that is required accordingly. Okay, so whatever the amount that we are removing, we call it as a machining allowances. Another example is we have discussed in the first video regarding the casting terminology when we were discussing, like whenever we are making a hollow part, okay, in between the mold cavity we are using the core, okay, and that is made up of the molding sand. Okay, so once the mold that molten material is solidified, okay, after filling in the mold cavity, so once it will be solidified, we have to remove that core part. Okay, so by using a small size diameter drill bit, we can drill inside this hollow part, and with the help of the equipments we can dig it and we can remove that material from inside. So here we are using a drilling operation to remove that part, so that is also a machining processes. Okay, so we call it as a machining allowances. Okay, okay, next is taper allowance, taper or draft allowances. Taper allowances, as the name suggests, that whatever the cavity or the casting at the end we will get, that is in taper shape. Okay, now first from this figure, first figure, that now you can see that whatever the pattern that we are producing, that pattern we are filling first, making the molding sand accordingly, and that is here the sand mold, bottom part of it is in drag, and above there is a coke part through which we are filling the molten material. Okay, so at the end we will get this type of shape, what pattern is there. Okay, but these vertical shapes, okay, if we have to remove this casting from the molding sand, then what we have to do, we have to apply force in this direction, that is a shear force. Okay, because that is a parallel to the cross section. First we have to applied force in this direction, then we have to apply it from this direction. Okay, so we can say that we are applying a shaking force, okay, or we are shaking it, and because of this shaking, whatever the corner of this molding sand, okay, whatever the sand is at the corner, that is broken out. Okay, also space is generated between this vertical pieces. Okay, so once this space or this material, the space is generated or the material from the corner is removed, okay, that time we can easily pull it. Okay, so this is a way. Or another way is if this vertical passages that we are using for the casting, in the casting, okay, so if this dimension of these vertical columns are lesser in dia or lesser in thickness, then it's very it's very difficult to shake it, because there may be chances of breakage in between. Okay, so what we have to do is we have to provide a taper section for that particular. Okay, now this taper will be the larger size of the taper portion at the top, and the bottom size it is smaller in diameter. Okay, so that easily with the very little amount of the shaking force, this material get distorted, or there is because we are using a taper section, so there is no need of shaking force, just easily can be removed by pulling it. Okay, so once we pulled it, whatever the excessive amount of taper that we have provided, we can with the help of the machining process, we can remove it. In the previous video, when we were study about these allowances, I also mentioned that anyhow these allowances are related with each other. Okay, so like you can see this in this taper section, we are providing the taper in the beginning, but at the end we are using the machining allowances to remove this taper portion. Okay, so next is distortion or camber allowances. These type of allowances can occur in I section, U section, T section or V sections, or where the thickness of the one of the part of the member is quite lesser than the length of the part. Okay, so generally I sections like that we are using in railway tracks. Okay, so that is produced with the help of the, nowadays that is produced with the help of the rolling process, but before it was produced by the casting. Okay, so when we are going for a casting of these type of equipments, okay, so once the material is solidified, when it is removed from the pattern molding sand, and once it's solidified, after some times the shape is changed, shape of these sections is changed. Okay, so for an example, like this is the required shape. Okay, and once we have prepared the pattern accordingly, and we have set it inside the molding sand and filled the cavity with the help of the molten metal. Okay, so once this casting is removed from the molding sand, this will be like, after some time this will be in this form. So this is basically, we call it as a distorted casting. Okay, so what we have to do is we just have to calculate the rate of deformation at the different angle, how much amount is distorted, and accordingly we will prepare a pattern. So that pattern we call it as a cambered pattern. Okay, so this type of pattern will have to prepare if such allowances is required. Okay, if such allowances occur, so that time we have to use this type of cambered pattern. Okay, so that we can get this type of required shape and size. Okay, next is rapping allowances. So rapping allowances means if the flask that is cope and drag part is there, and in between there is a mold cavity or the that casting that we have prepared, if we have to remove it, just what we will do is with the help of the hammer, we just we'll just hit it outside the from all the surfaces through which this breakage of the molding sand takes place, and that casting is easily removed. Okay, so these are the 5 allowances that we have studied. If you will study, there are different books are available, so if you'll go through that, you will get to know that there are different types of allowances is also available with a different name. Okay, but as I told you in the previous video, that anyhow these allowances are related with each other, so need not to be worried about. Okay, so these are the allowances. Next we are going to discuss about the molding sand, its molding sand composition, types of sand mold, and its properties. Okay, so molding sand composition is nothing but whatever the molding sand that we are using in the casting, its composition only. Okay, so what are the things that this composition include is, first is base sand, and this base sand is silica sand only, and that silica sand, that what is available in nature, that we call it as a silica sand. Okay, next is binder generally used to provide a bond between the molding sand, means between the sand and the other particles that we are using. Okay, so it provide a bond between that. Okay, or bonding agent we can say it. Okay, next is water content or the moisture. Okay, in some of the types of the sand mold it is required, in some it is not required, so we'll study in which it is required in next slide, but just keep in mind water should be there. Okay, next should be next is additives. Okay, additives are generally it is not basically the part of composition, but it depends on what properties is required at the end for the molding sand. Okay, so if it depends, like properties are like surface finish will be good, so that accordingly we have to add the additives. If the strength is required, if the collapsibility is required, so accordingly we have to prepare, we have to add the additives. Okay, so these are basically the 4 things that is required to make the molding sand. Okay, now there will be different types of sand molds. Okay, so these sand molds are defined on the basis of these percentage of these elements what we have discussed in the last slide, as well as the different types of binders. Okay, so there are 3 types of sand molds. First is green sand mold, then second is cold box mold, and third is no bake mold. Okay, green sand mold is basically the combination of silica sand, clay binders, and the water content. Okay, if whatever the property is required, we'll add the additives accordingly, but these 3 are the common element. Okay, for the green sand mold. Now when we are using this green sand mold, the silica sand in the range of 70 to 80%, 70 to 75%. This clay binders, we call it like kevlonitic solution or bentonitic solution is available, so that we will use in this clay as a clay binders. And water content, that is in the range of 2 to 8%, and if this clay binder is 10 to 20%, or whatever the additives that we are using, that is in the range of 1 to 4%. Okay, next is one more thing is here is in this green sand mold is a lot of this one of the question that has been asked in the previous several PSUs previously, and also in the gate examination, regarding that this will it be in green color. That's why we are saying it, whatever the sand that we are getting at the end, it's molding sand, that will be in green color, so that's why we are saying it green sand mold. No, the answer is no basically. Okay, because why we are saying green, because the water content that we are using, because of that the moisture is increases. Moisture is basically because of moisture the wetness of the sand is increases, and because of this wetness, the dampness of the dampness of the molding sand is increases. Okay, so because of that we are calling it as a green sand mold. Okay, so please keep in mind these things. Next is cold box mold. Here silica sand, this cold box mold is a mixture combination of silica sand and the organic and inorganic binders. There is no water content. Please keep in mind that there is no water content, only silica sand and the organic and inorganic binders. Now this organic and inorganic we have studied in chemistry, so whatever the bonding is takes place due to the chemical reaction only. Okay, so that's why we are calling it as a cold box mold. Okay, in simply you can keep it with the chemical reaction, there will be the formation of the molding sand. Okay, next is no bake mold. No bake means there is no heating is required. So the combination is combination includes the silica sand and the synthetic liquid resin. Okay, so this liquid resin is basically it's a form of rubber. Okay, so this occurs, this bonding between the reaction is occur at the room temperature. So if it is occurring at the room temperature, then there is no bake heating is required, so that's why we are calling it as a no bake mold. Okay, so there is no excessive amount of heating is required. Okay, Next is molding sand properties. These are very important, because on the basis of these only we are adding the additives. Okay, so first is refractoriness, that whatever the amount of that molten material we are filling in it, whatever the molten material that we are filling, because different molten materials has a different melting points. Okay, so if that molding sand that we are using here is, if it has a ability to resist the temperature or the heat that is produced by the liquid material or the molten material, then means it has the ability so that it will not be fused, means that will not be distorted. Molding sand should not be distorted and should not become a part of the molten material. So that ability we call it as a refractoriness. Okay, next is porosity and a permeability. Porosity, you all are aware about that. Porosity means if there is a gases or air entrapment between the mold cavity. But permeability is also same, because during the pouring and the subsequent solidification of a casting, a large amount of gases and the steam is generated. Air is absorbed from the atmosphere and the steam is generated by the molding sand. Okay, so if these gases are not allowed to escape from the mold, they would be entrapped inside the casting and causes the casting defect, that is porosity. Okay, so to overcome this problem, the molding material must be porous. Okay, so porous means like you have seen that the material should be like some amount, there is a small holes are there through which this air can be vent. Okay, so that we call it as a permeability. Next is strength. When we are filling this molten material, this initially there is no material, then we are filling it, so suddenly the temperature rises, and after some time when the material gets solidified, the temperature decreases. Okay, so at the different stages the different strength of the molding sand is required. So first is green sand. Green sand we are saying because if we are adding a sufficient amount of water content, because of that the wetness of the molding sand is increases, so that we are calling it as a that strength that is produced at the time by adding of the moisture, we call it as a green strength. Okay, next is when the molten material is filled inside this cavity, that molding sand, okay, that whatever the temperature is there, because of that temperature or the heat that is suddenly came into the contact with this molding sand, this moisture is quickly evaporate. Okay, so once because of that heating, okay, so at this stage this molding sand must possess sufficient strength to retain the exact shape of the mold cavity. Okay, so that whatever that sufficient strength is required to retain the exact shape, we call it as a dry strength. Okay, next is hot strength. So the strength of the sand that is required to hold the shape of the cavity. Okay, so whatever the shape that has been curved by the molten material, this will be throughout the solidification. Okay, so we call this strength as a hot strength. So next is flowability. Flowability is basically the ability of the molding sand to flow due to ramming force. Okay, so means when we are adding a water content in the molding sand and we are continuously applying the ramming force. Okay, so as we are adding hitting means we are applying the ramming force, as the more water content will come, it will become a part of the molding sand, and there will be a limit, like both things come together, like ramming force and the water content. But there after that limit, if you continuously add the water content, that water will not become a part of molding sand. Okay, so that we call it as a flowability. Okay, so the next is collapsibility. Okay, so the collapsibility is it depends, like it's basically depends on the rate of contraction, because during the contraction of the casting material, if the mold walls will not offer any resistance against the contraction of the casting. This is known as the collapsibility. Okay, so I think it's basically the, in other words, you can say that ability of the molding set to decrease in volume. So decrease in volume because of the rate of contraction. That's why we are adding that allowances we are adding, that shrinkage allowances we are adding into the pattern. Okay, so we have to keep in mind that is contraction, that rate of contraction that also causes the collapsibility of the material, okay, of the molding sand. Okay, next is the fluidity. Fluidity is the capability of the molten metal to fill the mold cavity. Okay, this is basically the definition of fluidity, but it depends on two factors. First is characteristic of the molten metal and the casting parameters. Now when we are talking about the characteristic of the molten material, that is liquid material, there that time the characteristic are viscosity and the surface tension. When we are talking about the casting parameters, then that depends that pouring temperature, freezing zone, heat transfer rate, mold design. Okay, so these are basically the parameters that depends that casting parameters. Okay, next is a problem that has been asked in the GATE 2011, that green sand mold indicates that. Okay, so the options are polymeric mold has been curd. No, there is no polymeric mold. Okay, it's basically the water content, moisture is there. Okay, and the binders are also clay binders. Okay, next is mold has been totally dried. No, it should not be dried because we are adding the moisture, so it would be wetness should be there. Okay, next is mold is in green in color. No, as I already told you at that time, that it would not be in green color. It's green. Green sand we are saying because water content we are adding. Okay, next is mold contains moisture. Yes, because we are adding the water, and that water causes the moisture of the moisture in the green sand mold. Okay, so the correct answer is D. In this video we are just stopping up to here. In next video we will discuss about the gating system and its design. Okay, so thank you so much guys.